Hello, in this video we will use matrix solution for saturation growth model polynomial regression and use LINEST to draw the trend line of this dataset. Let's begin with the chart and we use the scatter chart and show the series trend line polynomial, and we'll get a closer fit using the polynomial degree 3 and show the equation as labeled. So here we have the equation and the dataset. You'll notice the dataset is saturating to the value of 10, and the equation is y equals 2.59 plus 4.16x minus 0.756x squared plus 0.0412x cubed. So our BO is 2.59, B1 is 4.16, our B2 is negative 0.756, our B3 is 0.0412. We'll calculate this using the matrix solution and the LINEST function. We begin with the formula or the equation, which is y equals b0 plus b1x plus b2x squared plus b3x cubed. We factor out into the matrix form the coefficients and the x values. So we have the first matrix 1 comma x squared comma x cubed, which is this matrix, followed by, that's multiplied by b0 semicolon b1 semicolon b2 semicolon b3, which is this matrix. We're going to derive this matrix. We begin with the transformation of the dataset into the polynomial form, or the formula of the y values that fills up the y column. Then the 1x or the x matrix, start with the 1 column, then the x column, which is RA formula of the x values, and the x squared column, which is RA formula of the x values squared, or raised to the power 2. And then the x cubed column will be RA formula of the x values cubed, or raised to the power 3. Next, we calculate the Pijarina inverse. But before we do that, let's try the LINEST. The LINEST, we just enter because we have transformed the dataset into the polynomial form. We have LINEST y values, data y, and data x. Here we have B0, 2.588, which is rounded off as 2.59. B1 is 4.15899, rounded off as 4.16. And B2 is negative 0.75597, rounded off as negative 0.756. And B3 is 0.041238, rounded off as 0.0412. We can also calculate using the matrix solution. We have min inverse, starting with the Pijarina inverse, min inverse, M mult, transpose of the X matrix and itself. And we calculate the Picharina cofactor, which is M multi transpose of the X matrix and the Y values. Then we calculate the coefficients, which is M multi of the Picharina inverse and the Picharina cofactor. You will notice B0 here is 2.588, matches to our LINEST output and our chart equation. B1 is 4.1589, matches to our LINEST output B1, and rounded off as 4.16 in the chart equation. B2 is negative 0.7559, matches to our LINEST output B2, and rounded off as negative 0.756 in the chart equation. And B3 is 0.0412, matches to our LINEST output and the chart equation. This completes the polynomial regression analysis for such a saturation growth model using both matrix and LINEST